I want to make a mecha game about shooting bugs. And that means the bugs have to do things, you know? On their own. I can't hover behind every player in every game, controlling every single bug that attacks them. I don't have that much power. In games, I know this is generally done with behavior trees, so I looked for a behavior tree library for Godot and found Behave. It's good. You can tell it's ideal for designers to use. Nice GUI controls, visual debugging tools, and really, the most important thing, someone else wrote it and I don't have to. It's a great choice for implementing AI in your game. It seems like it would be the perfect thing for me to use in my girl-kissing disaster mecha game, Decimeter. I'm a lazy developer. I generally prefer making my games to making tools to make my games. I've never made a behavior tree either, so obviously it should be better to use something someone more experienced than me has made. Behave does, by all means, meet the requirements you might have for AI in a new game project, but I don't like it. I mean, look at this. Look at what they expect me to deal with in the year of our Lord 2026. We need to use inheritance? The functions are basically untyped? First, let's talk about inheritance. Inheritance is part of a paradigm, a way of doing things known as object-oriented programming. In my eyes, object-oriented programming is almost always a bad choice, and the software industry has largely recognized its flaws. In spite of this, the video game industry at large still embraces it, especially Godot, the engine I'm using to make this game. But this video is not really about the flaws of object-oriented programming. It's just, because Behave adopts it, there's one very annoying problem. There's too many goddamn files. Whenever I want my AI to perform a single action, I have to create a new class, which inherits the ActionLeaf class, and each of these classes have to be in a separate file. It makes sense that Behave does this. Normally, you would want a developer to implement the behaviors that a gameplay designer can then later weave into an interesting AI. But I am the gameplay designer.
Look at me, sure. Look at me, sure. I'm the
designer. And writing short snippets of code keeps me closer to my flow state than having to manage so much boilerplate every single time I add a new thing I want the AI to do. Then, there's a lack of type information. When you inherit ActionLeaf, we need to implement a function whose type signature looks like this. You might rightly point out that actor does have a type, but we only know that the actor is a node, one of the most abstract base types available in Godot. We don't really know anything about what type actor is. It's close to being useless type information. You might also say, well, we know that this action will never be called with anything other than the bug type. But in such a situation, it's important to recognize that the compiler will never be able to help us. Since we didn't give the compiler enough information to make sure that this is always true automatically, it's now up to us to make sure this is always true. And I'm lazy. I would much rather prefer it if the compiler slapped me in the face and told me to do it right, instead of running the game and finding out 3 hours into a play session that something is wrong. Enter Neuron, a stateless behavior tree library for Godot, which I wrote to delay the production of girl-kissing cinematics by at least 3 months. Let me show you how it works. Say, I've got a little guy here who can move to the right, like this. This little guy doesn't do anything on his own yet, because they're not thinking about anything. They've got head empty syndrome. There's nothing in there. Like me, some days, or my cat most days. So let's give them a brain and a single brain cell. This is a very simple behavior tree, but you can see that we've avoided several type safety issues. Go right is always going to succeed because it has a direct reference to this instance of little guy, and if we ever rename go right, the code will stop working at compile time until we update all references to it. All of the code is also in one file, which makes it easier to find everything. Oh, right, and then we need to actually tell them to think. And there you go. Now our little guy moves to the right. Red Luigi would be proud. Isn't this great? For comparison, in Behave, we would have to wrap our function call so it can be added to the scene tree, and just be okay with the typecast. In Neuron, we can call the function directly. So yeah, that's what's driving the design behind Neuron, and a small peek at how it works. I wanted to use something easier to maintain, and that guarantees more things upfront at compile time, rather than fucking around and finding out at runtime. I think it's really cool, and I can't wait to use it in Decimeter. Now, the only problem is I've never designed an AI before. If you like this video, please consider subscribing to my brand new newsletter at buttondown.com/exodrifter. I link to all of the cool things I'm up to that the algorithm won't tell you about, like what I thought about GDC 2026 and the cute Yandere Mickey music I'm listening to. Finally, thanks to my Patreon, Ko-Fi, and Discord patrons who are currently supporting me. I love y'all. Hope to tell you more about Decimeter soon.